Hi everyone. I'm Dr. Sundarlin Shibu, Associate Professor in the Department of Biomedical Engineering in Sedu Institute of Technology. In this lecture, I am going to explain about the origin of biopotential, how the biopotential is generated in human body. Okay. Initially, the introduction, the origin of bioelectric potential. The systems in the human body generate their own monitoring signals when they carry out their functions. These bioelectric signals provide useful information about their functions. The bioelectric potentials are actually ionic voltages produced as a result of electrochemical activity of certain cells. The transducers are used to convert this ionic voltage into the electrical signals. In this origin of biopotential, initially we should know what is resting potential. The resting potential. Let us assume this is a cell membrane. It's a cell membrane. Cell inside the cell there is cytoplasm is there. Cytoplasm. Outside the cell also there is your body fluids are there. Okay, in this body fluid there is uh, sodium, potassium, chloride ions, so the principal ions are there. Inside the cell membrane, potassium and chloride ions are higher in concentration. Inside, potassium and chloride ions are in higher concentration compared with the outside. The outside there is sodium ions are higher in concentration. Okay. Because the cell membrane allows the potassium and chloride ions but not permit to allow the sodium ions from outside the cell membrane to inside the cell membrane. So in this time we measure the potential inside the cell membrane means it will becomes negative. The voltage varies from minus 60 millivolt to minus 100 millivolt, approximately minus 70 millivolt. This potential is called resting potential. The cell is in resting stage. In this time we measure the potential inside the cell membrane means you will get the potential in negative. That is approximately minus 70 millivolt. This is resting potential. This cell is in resting state. It's called the polarized stage, polarized cell. So this is called resting potential. Okay, the cell is in resting stage. This time the cell membrane should not allow the sodium ions from outside to inside the cell membrane. It permits only the potassium and chloride ions. This time inside the cell membrane is negatively charged compared with outside the cell membrane. Inside there is a negative charge. We measure the potential inside the cell membrane. We will get the minus 70 millivolt approximately, minus 60 to minus 100 millivolt. This potential is called resting potential. Okay, resting potential. The principal ions are sodium, potassium, and chloride ions. The membrane of excitable cells permit entry of potassium and chloride ions, but blocks the entry of sodium ions. This membrane potential is called resting potential. This potential is measured from inside the cell with respect to body fluids. So resting potential of the cell is negative. Then a depolarization of cell, the action potential. Okay, when a cell is excited, the membrane changes its characteristics. Okay, when the cell is excited by external stimulation or any way, when the cell is excited, so in this time the cell membrane change its characteristics. Okay, so this time the cell membrane allows the sodium ions from outside to inside and it's potassium from inside to outside. So in this action stage, the sodium ions tends to move from outside to inside. So inside the Na plus ions, sodium ions are higher in concentration, and potassium ions are moved from inside to outside. So we measure the potential. The inside the cell membrane means it will becomes positive. Okay, so after this equilibrium state is reached, the sodium is moved back to the outside. Okay, this is called depolarization of the cell. Okay, so initially the resting stage, the cell membrane does not allow the sodium ions from outside to inside. But when the cell is in excited, this time this cell membrane changes its characteristics. So in this time, this stage, the sodium ions are moved from outside to inside. So inside will become the positive charge. So we measure the potential inside the cell membranes means will get positive or plus 20 millivolt. Okay, this is called action potential. Okay, then repolarization. In this action potential inside, the sodium ions are higher in concentration, but sodium ions are not uh, stay a long time inside the cell membrane. Okay, so in this time the sodium potassium pumping will be occur. So again the sodium ions are moved from inside to outside and becomes the normal or the original state. This is called repolarization. Okay, sodium ions are moved from inside to outside. Again, inside will become negatively charged, minus 70 millivolt. Okay, cell comes from depolarized state into polarized states called repolarization. Again, it's come to the original state. It's called repolarization. Okay, I think understood what is depolarization, then action potential, then repolarization. Initially, the cell is in resting stage. That time, negatively charged inside the cell membrane will get negatively charged or minus 70 millivolt. It's called depolarization. When we are exciting the cell membrane, so it will becomes when the exciting the cell will becomes action stage. Again, this action stage to the resting stage is called repolarization. Okay, this the process of changing the state from the original state to action stage is called depolarization. The process of the change in state from action potential to the resting stage is called repolarization. It's called depolarization, action potential, again repolarization. Nernst equation. Okay. The equilibrium potential for an ion can be calculated from the concentrations of ions on the two sides of the membrane using the Nernst equation. It's the equation for calculating the equilibrium potential for permanent ion. The Goldman-Coates equation. Okay, Nernst equation helps to calculate the equilibrium potential for each ion individually. Here, this GH equation, the magnitude of membrane potential at the given time period on distribution and permeability of sodium potassium fluoride ions. So this is calculated by using the formula. Okay, thank you.